Well, in order to make Minesweeper work, we have to interact with the board somehow, right? So when we want to reveal a square, it will reveal everything connected to it until the square has a number that's not zero, right? For example, if I just search up Minesweeper, like the first thing that pops up on Google Chrome, right? You click on something, well, it reveals everything around it until you hit a number, right? So we're going to do that. Now, well, what we have right now is just a board, right? And we don't have any ways of interacting with it. So why don't we, well, make a way to interact with it, right? So, well, we could say, well, true, ask for some input, right? Ask for, enter, a square to reveal. But then how do we do that, right? We need to know the row and the column of the square. But now, counting the row and column right now is kind of difficult, right? So, well, what do we do, right? Because say, well, on the first line, right, we could have row and column at the top. We could have the columns. That's actually pretty easy to do. All we have to do is, well, add something on top of the top row, right? No, well, what do we need? We just need numbers 1 through 10, right? Now, what's the easy way of doing numbers 1 through 10? Suppose we have like range from starting from 1, ending at 11. Now that's just 11 is exclusive. It's exclusive, so 11 is excluded, so it's only actually 1 to 10. Now, like I say, using the map function. Now, all this does is that it applies a function to everything that's in it. Well, that's kind of complicated. So, well, here's the easy way to do this. So we can have output initially equals, well, empty string. And here we have plus equals, right? So that we're adding this to the empty output. Now before that, we could say for I range from 1 to 11, and then output add, well, the number to output, but in the string form, and add a space after it. And then well, not dot add, but output. You can add, well, the new line character, which is \n. Well, I suppose let's try this again, and yay, here we have rows and columns now. But they're kind of offsetted to the left, so let's put a space in front of it. Let's put a space in front of the numbers. So now here we have centralized board with the numbers. Yay. Now, what do we do about the vertical lines? We want numbers on the left too, right? So, well, instead of for line, self.board, we could say like for I in range of length of self.board. And well, let's just say line equals self.board at the ith element. Well, this does the exact same thing as before. But now we have access to, well, this I, which is the index. Now we know which row it is on. So we could say, well, instead of just a line, we could have the number on the left too. Add the string version of I plus this. Well, no, everything's shifted to the right except for every other row, right? So, well, we could just add a space in front of it. So, not just in front of that one, but in front of every single line. Well, I suppose I could just add a space here. But now, everything should be formatted and, well, ready to go. Oh, do you guys prefer 1 through 10 or 0 through 9? Oh, let's just go with 0 through 9 then. Has Replit been frozen for me? Perhaps. Let me try to reload this page. Yep, it works. Yay. So we have 1 through 10. All right. So 1 through 11. And then for the other one, self 0 through 9. All we have to do is I plus 1. So this will change it from 0 through 9 to 1 through 10. Now, as you can see, the last line is a bit offsetted because, well, 10 is 2 characters. So we could say for every other character, every other line, we can add a space. We could say, well, plus. Plus, well, space. And then output plus equals the line again. Now, why do we do it in separate steps? Well, if the number, well, it's less than 10, realistically less than 9, because when I is 9, the number that shows is 10, right? Index will start from 0. So if I is less than 9, then add the space. Otherwise, it's 2 characters and you do not need to add the space. So here we go. Now we have to offset the top part again. So all we have to do is, well, add another space. And, well, that goes for the top number too. Oh, that was one too much space. So now we have, well, 1 through 10 for the rows and columns, right? So now we could say, well, true. We'll change it true to something else later, but for now, let's do while true. We could say input, enter a square to reveal. And in terms of row and column, and then, well, we could say next line. So now you can enter a row and a column, except it doesn't do anything yet, right? It just asks for input. Now let's make it do something, shall we? So let's make, first of all, right now, when we enter 1, comma, space 1, it's just 1 and 1, right? So, well, let's make it two numbers, a row and a column, shall we? So what we can do is, well, first, well, what shall we name our input? Let's call it a play, shall we? A play. Now, right now it is a string, right? So for strings, you can do strings.split, and inside the parentheses, type what you want to split it on. So if I say comma space, it will split it when there's a comma in the space. So now this will split into 1 and 1. So if I say row and column equals play.split, well, let's print row and a column, shall we? And then it says 5 and 5. So now we have successfully extracted those row and columns, right? See, but for the computer, row 5 is actually at index 4. So, well, row equals, first, it is still a string object when you split it. So you want to make it into a number. And then subtract 1. Same thing goes for the column too. You convert the column to an integer and you subtract 1. Now we have a row and a column, right? But now we need to reveal this actual square, right? But how do we do that, right? How do we go about revealing a square? Well, let's make a reveal function in the board class. Let's say define reveal and have row and column. For now, let's just say self dot, well, I forgot about it again, but you always need self as a parameter. Self dot board at row and column. So that square. Let's reveal that square. I could just set dot reveal equals true, but then if we were to change anything in the square, then we need to change this too. So instead, we can make a function in the square says define reveal self. Well, it's pretty simple. Self.revealed equals true. Now, why do we do this? It's so that if we change anything in the square class, it would not affect how we use this in the board class, as long as it does the same thing still. So now, well, let's do board or reveal at row and column. Now let's give this a try, shall we? So if we reveal 5 and 5, and well, let's display the new board after we reveal the square. So now look, yay. What even is the website link? It's replix.com, right? Replit.com. Well, if you make a square to reveal 5, 5, well, it reveals a square, and you can reveal a new square too. When you Minesweeper, when you reveal a square, it reveals everything around it, right? So, without this, well, let's make it reveal everything around it, right? But how do we go about that? Well, let's just make every square we revealed, it will try to reveal every square around it. Well, let's just say if before you reveal yourself, let's say if oh the board at this square is not revealed yet, if it's revealed already, then don't do anything, right? If it's not revealed yet, reveal it and try to reveal everything around it. Oh, self-dot. Try to reveal the row and column of everything around it. Now if we're doing this, we have to check that the row and columns are not outside the board. So let's say if I'll be in front of a not, let's say if 0 is less or equal to row and it's less than 10, and well, same thing for column. And everything, if everything is, the positions are all legal, and if it's not revealed yet, reveal it, right? Now, if it's not a number, then it will reveal the things around it too, right? So if, well, self.board, arrow, column, well, it has number, right? If the number is 0, then it will reveal everything around it. So now we could just write 9 reveal statements, but that will be kind of lame and we have to copy paste a lot, right? So we could say for offset, for row offset in, well, -1, 0, and 1. And for column offset, well, the same thing. And try to reveal the row and column with the offsets applied. Now this will also call it 9 times. And now when we make a square to reveal, say 5, 5. Well, oh no, it was not supposed to reveal all of this 0, right? Now, what do you suppose happened? Well, it revealed 5, 5. And I tried to reveal the things in the left of it too. So now we have encountered a problem, right? This part is not working as intended. Oh no. So this works. But when we try to propagate the reveal and try to reveal everything, it doesn't quite work, right? So we said if the number is 0, then well, try to reveal all the things around it. Now really what we could do, instead of trying to call the function itself and trying to figure out what is going on, well, we could just say we can have a list that's to reveal, right? So instead of this, we could say, well, to reveal equals empty. And well, we could say to reveal the append the square, right? Or simply, well, let's just append the square to reveal. And we can say while to reveal is not empty, right? So if you say if the length of to reveal is greater than 0, then keep revealing things it's supposed to reveal, right? To reveal at 0 is the thing we're trying to reveal, right? So we can say square equals to reveal at index 0. But now we also want to remove it from the list because we're trying to reveal it, right? So we can say to reveal, remember pop and index. Well, this will return what's at index 0 and also remove it from the list. We talked about the pop function. And well, if square the number is 0, then we want to add everything around it to the to reveal, right? So if it's 0, then it will reveal everything around if they're not revealed yet. So we can do the same thing for row offset. Being, well, -1, 0, and 1. And also for column offset, the same thing. We could say if self.board at row plus row offset and column plus column offset. If it's not revealed yet, so if it's not revealed yet, then, well, to reveal dot add or append. Well, what do we append? We append this square. So we append this. So if we now reveal 5 at 5, it's taking a while. And it's kind of freezing, right? Well, what happened was that I tried to reveal too many times and add too many things to the list. If it's not revealed yet, add it to the board. No, they could be trying to add the same thing, right? They could be trying to add the exact, so suppose the square in the middle and the square on here, all try to add the square they're both next to, then, well, this square will be added twice, and maybe 3 times, 4 times, who knows, a lot of times. So now, if you add the same square too many times, what could happen is that, well, the entire program stalls because you're trying to add too many things. So now, do you guys want to take a guess how we fix the problem? Here's this magical thing called a set. And set does not have indexes, but it also doesn't allow duplicates. So we could say to reveal dot, well, add. Well, we could still say if the length of two reveals greater than 0, and well, the square is not to reveal anymore because in order for the set to properly work, we need a tuple of row and columns as the coordinates. So we, instead of that, we can just say, well, square equals row and column, right? But the thing is, it doesn't support indexing, and we have no ways of just randomly copying a thing from the set. So now, oh no, right? So we have to implement a way that will allow us to reveal everything that's a 0 that is also connected to the thing. So if it's not revealed yet, well, try to reveal it. We can just try to reveal it. Reveal, try to reveal it, right? Row is row plus row offset, and column is column plus column offset. You know, this will just try to reveal the squares around it and see if they're not revealed yet. Well, if it's already been processed and revealed, it's not going to reveal it again. But we need to make sure that, well, you're not trying to reveal anything outside the board still. So let's actually add that back, right? Row, if row is less or equal to row, which is less than 10, and same thing for the column. Well, suppose we don't have the to reveal, and we don't have the while. And it's just blindly trying to reveal, well, everything around. What will happen now? Oh, it says square does not have a number. because we did not define square, right? So instead, we can just say self.board at row and at column. Now when I try to reveal it, well, it gives you an error that maximum recursion depth exceeded. No, that is not fun, is it? So, well, that just means you have too many zeros. Well, what possibly happened? We did not reveal the thing itself, right? So we have to reveal the square itself. That's where we went wrong. Oh no, index out of range. Now what happened? Well, we did not check if it's actually a legal index. So let's say if everything is legal, the index is a place all valid, and they're not revealed. Well, it still says index out of range. Because, well, you have to make sure it's row plus row offset at column plus column offset. The target location is within the range. Now, look what we have. Everything is revealed because it's all zero for now. So now we have figured out a way to reveal everything that is connected. All right. Who has questions so far? I'm sure you guys do have some questions, right? Yeah.
I still don't get like
Get which part? Which part do you not get? Can you tell me? Or is it just the whole thing?
was there like a class like before?
Yep.
Oh,
Here. So last time we made, well, we defined the square. And then we also defined the board, which was kind of long. Well, I could just, since this is actually, I could just invite, I guess, and then I will send this in the chat so you can just see this page on, well,
okay.
yep. So, yep. So if you click this, it will let you in this and you can see what I'm doing. Yep. So well, all we did is that last time we made a square. Yep. We made a board and we defined how it's supposed to be shown on the screen. And now we just made how to reveal all the boards. So when it tries to reveal, right, it reveals the square itself that you try to reveal, and it tries to reveal everything connected to it. So this is the 2 for loops. If it's 0, it reveals things around it. Well, the thing you're trying to reveal also has to be within the board and not revealed yet, right? So this is what this if is for. And this reveal is just, well, call the same reveal function. and try to reveal that square too. And try to make it reveal everything else as well. So now this will make everything revealed for now, right? But now, ooh, let's add some lines too. Shall we? Let's see. We can, well, define add lines. And then we need, well, say how many lines we need. We can call it n for now. Well, lines left. So how many lines we have to add right now? Well, let's just call it n. Or actually, we can just have n, right? Lines left equals n. Well, lines left is, well, if we still have to add some lines, then, well, choose a random location to make it a line, right? So rel equals random dot randint, remember? This picks a random integer from 0 through 9. Well, the column goes to 1 through 10, well, the index is 9. So you can say row and column. And, well, try to make it a line, right? So self and n. So if, well, self dot board at row and at column. So if that location, see, we have a is dot is mine, right? So if it's not a mine yet, if it's not a mine, then we'll make it a mine. So self dot board arrow colon dot is mine. We can set it to true. And mine's left. And subtract equals 1. Now this, instead of using a for loop that loops 10 times, the purpose of this while is that in case the random location, in the unlikely case that you chose somewhere that is already a mine, well, you have to choose somewhere else, right? So as we can say, b equals board. And when you initialize a board, well, you have to add some mines too. So you can say self.add mines. Yeah, 10 by 10, let's add 10 mines. And well, that's just adding the mines, right? Now in Minesweeper, the number represents how many mines are around the square. So so you have to, whenever you add a mine, well, every square around it is added by 1, right? So what we can do is we can copy and steal the part we did from reveal. Copy and, well, paste. Except we have to make this here. And we don't need the revealed part. If it's within the board, then self.board at row at column dot number plus equals 1. We don't want to make the number increase by 1. So now, well, oh well. It has 9 mines around it. Right? The 9 just means, well, oh no, we got stepped on a mine. And the 6 here, well, also not good. So let's give it another try. No, it just instantly revealed everything. Right? So let's say that it just reveals everything regardless. Except when we hit a number, we want to hide it, right? So let's say, well, if it's, well, if self.mine, well, is mine, let's make it a star. We can say else if it's revealed, then now we know the mines are here for now. So if we do 5 and 5, well, it didn't quite work, did it? It did not actually successfully add anything. So when we add the mines, this part did not work as intended. Oh no, but now this is it's just bug fixing, right? It's a part of programming. We have to make the mines update the squares around it. So when we add a mine, mines left is one less. And, well, for everything around it, if it's within the board, the number, well, it should go up by 1. Row plus, this is where we forgot. Row offset and column offset. So now when we try to reveal a square, well, it reveals everything, but we also know where the mines are, so that's not good. We don't want to know where the mines are. So if it's revealed, and well, if self is mine, well, if you reveal a mine, you lose, right? But regardless, if self is mine, then we want to return a star for representing mine. And if it's not, then return the number, right? So now we have, well, 2 here. So we know there's two things, two mines around it. So now we have a game of Minesweeper that somewhat works, right? Yep, play around with it. Try it out. It's basically already half working. We have the number system work, and it reveals everything around it. And well, if you just try to press enter without typing in anything, it gives me an error for now, right? So what I can say is, well, try this. And well, accept, print, invalid, invalid input. And we can put this in here too. So try this. If it doesn't work, it's not a valid input. So now if I type, just try to enter empty if it's invalid input. So now I'm forced to, well, enter a valid input. So now Well, this is basically a game of Minesweeper, except you don't know if you have won or not. Yep. So to review a square, you just type number, comma, space, and the number. Oh, for example, let's reveal 6 and 3. No, that's a 2. Oh, and we can also reveal 7 and 3. That's a 3. Interesting, right? Now we're actually, well, missing a few features. So if you look at the actual Minesweeper, you can actually flag it. You could make a flag. Well, let me just click on a bomb. Oh god, that's a lot of mines. But well, you can right click to flag a mine to help yourself indicate that it's a line. It's yeah, 8 comma, and then you have to type a space. Yep, 8 comma space 1. Oh no, space before the 1. Yep, and then you're good. There you go. Go for it. Now we have, oh, Minesweeper that's somewhat working. Four and 8. That's a mine. Oh no. See, when we have revealing a mine, you should lose, right? The bomb blow up. No, yeah. So well, let's add the when you reveal a mine, you lose. So well, let's add, well, self dot lost equals false and self dot won equals false. So now we know when we win or lose, right? So well, when we call the reveal, right? And well, and if the thing you're trying to reveal is a mine, then you lost, right? So if self dot board at row and at column, this represents the square you're trying to reveal. And if it's mine, then you lost. So return as well, just terminate the function, and I will end the function. And I will not try to reveal anything else if you click on the mine. So before we return, let's say self dot lost equals true. Now instead of while true, we can say how not board dot lost and not board dot won. So if you haven't won a game or lost a game, then keep doing this. And then after it, well, only one of them should be true. So if b dot lost, print you lost. Else, well, if b dot won, print you won. Now we don't have means of detecting if you won or not. But now if you try to reveal a line, mine, it should let you lose. What does it say? Board object has no attribute lost. Oh, I added in on the wrong class. See, that's a silly mistake on my part. Won and lost. So now, if you try to reveal a mine, it says you lose. Yep, give this a try now. 4.5. Well, that's a 4. Oh, there's 4 mines around it. Yeah, good job. You haven't stepped on a mine yet. Ooh. Mhm. Pretty risky, huh? Oh, let me just give you a hint. 1, 2, and 1, 4 are both safe. And 1, 5 is a mine. Yeah, 1, 5 is a mine. Yep, hey, I called it. See? I am actually pretty good at Minesweeper myself. Well, I suppose these numbers placements are kind of confusing. Let's move them to the right by, well, 1. No? Yeah. Well, in the Minesweeper game, if you lose, it also tells you where all the mines are. So, well, let's do that. Right? Peter lost. Reveal mines. Let's make that function. No, well, it's actually pretty simple. Define, reveal mines. Self. And well, all we do is, well, for line self board for square in line. Well, remember it's a listing a list. If square is mine, if it's a mine, then reveal it. So now if you lose, well, it says invalid syntax, which, well, it's valid, it's just lagging a bit. Yay. So now if I click on mine, so if I do 2, 3, it says you lost. Oh no. Reveal mines will print B again. Right? Now, let's give it a try. Let's purposely step on mine. Says you lost. And it tells you where all the mines are. What? Wanna give it a try? Roll space colon. Yep. Ooh, it's a 1. Yay. So this is all we'll do for this class. And well, if you want the link or if you want to take a closer look at it, the link is in the chat still. And yeah, so we have, well, half working Minesweeper now. And next time we will be adding, first of all, remember the very important feature is being able to flag a square. Flag a square so that we can remind ourselves it's a line and we cannot accidentally reveal it. Oh no, what has happened? It has stopped running. Someone has clicked stop. Yep. Yep, try to run it again, and here you go. Yep. Now click the stop, or it will. Yeah. Well, there are some features in Minesweeper that we haven't had yet. First of all, it's flagging. Second of all, we don't know if we have one, right? And third, well, we don't like we. So imagine if you try to reveal somewhere, and it turns out to be a mine. The first reveal, it will move the mine to somewhere else random. That's how Minesweeper works. So if I play, well, an easy Minesweeper, right? I can say, oh, well, here's a mine for sure. So I can say this, these two, right? No, these two are mines. So I know this is not a mine. And these two are both mines. These two are safe. And this is a mine, right? You could play this game without flagging, but it sure is very difficult. I will give you that. So if this is a mine, then this is perfectly safe. But you see, without flagging, you have to visually remind yourself where's the bombs, right? Where are the mines? And that could be quite a difficult task to try to do that. Yep. You guys can give Minesweeper a shot, the version that we just built together. Yeah, 5-7. Good job. That revealed a lot. So now see you have one. Yeah, but yeah, you lost. Oh no, you tried to reveal a mine. Oh no. Yep. So next time we will be adding how to flag a square and as well as detecting wins and some quality of life features like if you try to reveal a mine on your first try, you lose. Yep. But anyways, yep, that will be it for this class and